So, dengue fever is a disease transmitted by the mosquitoes, and the species involved in the transmission of dengue viruses in humans is the Aedes aegypti. It has now become a major health problem that is difficult to control in Malaysia due to the climate change and the tropical seasons. So there is a continuous rise in the reported dengue infected cases in Malaysia, and Selangor contributes 90% of the dengue cases in Malaysia due to large number of construction sites and unplanned urban development. So one of the methods that can be utilized to monitor or prevent the disease is by using a disease mapping. It can also identify the high-risk locations that require further government attention in terms of medical treatment, health supply, and societal awareness. The standardized morbidity ratio SMR method and the Poisson-Gamma method are used to estimate the relative risk value of the dengue fever in disease mapping in this study. The relative risk is the ratio of the risk for an event for the exposure group to the risk for the non-exposure group. For example, if the relative risk is less than 1, means that the state inhabitants are less likely than the overall population to suffer from dengue fever. If the relative risk is more than 1, means that the dengue fever is more common in the state residents than in the overall population. However, if the relative risk is equal to 1, means that there is no significant differences in the likelihood of the state inhabitants contracting the dengue fever compared to the overall population. The relative risk value is calculated using Microsoft Excel and Winbugs software in this study, and the results are displayed in time series plots and table. The dengue fever disease map were then created using the AZIZ software based on the relative risk calculator. So the formula is as below, and the expected dengue fever cases is calculated by using the formula below, which the n is equal to the population in the certain area. And then the Poisson-Gamma method is based on the exponential prior distribution with a Hilbert parameter of 0.1. And then the parameter of theta IJ has a gamma prior distribution with alpha and beta parameters. And the distribution is as shown as below. All right, so the data set in this study is obtained from the Department of Statistics Malaysia, DOSAM, and it contains the dengue fever cases of the 15 states in Malaysia from the year 2011 until 2020. So the dengue fever data for Putrajaya is included in the statistics for the states of Kuala Lumpur and Putrajaya, which is written as WP, Kuala Lumpur, and Putrajaya in this study. So regarding a result and discussion. All right, so figure 1 and 2 shows the time series plots of the estimated relative risk value of the dengue fever in for the 15 states in Malaysia from 2011 until 2020. So figure 1 is by using the SMR method, while figure 2 is by using the Poisson-Gamma model. All right, from the result, we can see that from 2011 and 2013 to 2020, Selangor has the higher relative risk value, while in 2012, Labuan has the highest relative risk value for dengue fever. And then from 2011 to 2020, the relative risk value of Johor, Kuala Lumpur, and Putrajaya, Malacca, and Selangor is more than 1, showing that the susceptible residents are more likely to get dengue fever than the general population. And the relative risk value for the remaining 11 states is less than 1, meaning the residents in these states are less prone to overall population to contract the dengue fever. Okay, table 1 shows the frequency and the estimated relative risk of the dengue fever based on the SMR method and the Poisson-Gamma method in 2020. So using the SMR method and Poisson-Gamma model, the residents in Selangor has the higher chance to develop the dengue fever in 2020. And followed by is the Kuala Lumpur and Putrajaya, which has a high risk as well with 2.07. Then Labuan has the lowest risk of getting dengue fever in 2020 with a risk of 0.0254 and 0.0303 using SMR method and Poisson-Gamma model respectively. Figure 3 and 4 shows the disease mapping of the estimated relative risk of the dengue fever in 15 states in Malaysia in 2020. So figure 3 is by using the SMR method, while figure 4 is by using the Poisson-Gamma model. So from a mapping, we can see that Selangor and Kuala Lumpur, Putrajaya have been detected as a very high-risk areas due to the high population density and the high volume of rainfall. And Johor and Malacca have been categorized as medium-risk areas, followed by other Negeri Sembilan, Pahang, and Kelantan, which have been identified as low-risk areas. And then Perlis, Kedah, Pulau Pinang, Perak, Terengganu, Sabah, Labuan, and Sarawak are identified as very low-risk areas. And there is no state identified as high-risk areas. To conclude, from 2011 and 2013 to 2020, Selangor has the highest relative risk value, while in 2012, Labuan has the highest relative risk value for dengue fever. The residents in Johor, KL, and Putrajaya, Malacca, and Selangor are more likely to get dengue fever as the relative risk values are more than 1 from 2011 to 2020. While the residents in the remaining 11 states are less likely to develop the dengue fever as the relative risk value is less than 1. So from the time series plots, it is better to utilize the Poisson-Gamma model to evaluate the relative risk instead of using the SMR method, as the estimated relative risk value range of both time series plots is reduced from 3.1176 for the SMR method to 3.0478 for the Poisson-Gamma model. So in 2020, the residents in Selangor have the highest chance to develop dengue fever because it recorded the most dengue fever cases and the highest relative risk value. And Labuan recorded the least dengue fever cases with the lowest relative risk value. And from a disease mapping in 2020, Selangor, KL, and Putrajaya have been identified very high-risk areas to develop the dengue fever due to the high population density and high volume of rainfall. Johor and Malacca have been categorized as the medium-risk areas. Negeri Sembilan, Pahang, and Kelantan have been identified as low-risk area. Perlis, Kedah, Pulau Pinang, Perak, Terengganu, Sabah, Labuan, and Sarawak are identified as very low-risk area, and there's no state identified as a high-risk area.